So, hello everyone, welcome on a highlighted speech from the statistics session. Today we have Daniel Aleman Hernandez, Senior Data Scientist at Global BPM at Chroma. His talk will be the key metric for your forecast is trust. And the description is about that usually data scientists focus on which language, package, type of problem to solve, technique to apply, what metrics to validate the model, and so on. But his own experience and studies have shown that people, the final users, are distrustful of automated model for forecasting. In this presentation, Daniel will not only share his experience using different techniques to have the best forecast analysis, but will disclose the journey to gain the trust of business over the project. Thank you for joining, Daniel, and for your patience. I hope we can get a lot of experience out of this presentation. So yeah, please share your screen and let's get this started.
Sure. I will share my screen. Can you see it?
Yep, nice and clear. Good luck.
Okay, perfect. So first of all, I would like to say thank you to Martin and to the whole team, because I believe that this is a volunteer work, or partially, and you are doing a really great job to keep this conference alive, even with the current situations that we have. So today, I want to present first myself. I'm a senior data scientist with over 9 years of experience in different type of business and companies like IBM, Eurocontrol, or Chroma that we're working currently. Chroma is a chemical company worldwide. I have different certifications. I'm really keen to keep learning. I love to learn. So yeah, that's why I'm a weekend here, just following a conference instead of doing a normal people weekend. No? So the talk is title is the key metric for forecast is trust. Actually, trust is one of the principles that when you start a project, let's say one of the fundamentals when you start a project, what is the things that you need to build from the scratch. First, when you get the project from the really beginning, you need to analyze the data maturity of the company or including the department. So maybe we are working as a data scientist doing insourcing, and we have different projects from HR, from sales, from factory, and we need to analyze because maybe even in the same company, not all the departments have the same data maturity. Definitely, really like all the modeling techniques that my colleagues on the YR conference are presenting, but we need to keep always on mind as a technicals that we are, that when we build the models, it need to be the right questions on the right time, because otherwise it's not bringing value to the business. This is the third fundamental. And the last, and the one that I'm coming to talk to, is trust. But to be honest, about talking about trust, I was applying during the last 4 or 5 years of my career trust as a fundamental for any project. But the thing is that I was not having a proper definition. So when I submitted this abstract to this conference, I was trying to look for actually a proper definition. What is trust as a metric for a project in data scientist? And I find out that there is already a research data alliance that is a community supporting standards from European Union. They already do some small definitions, but this definition they are applying only to data repositories. So let's say GitHub repository or any type of system for code repository that are treating and doing data analytics. So when we focus on what is the trust itself, so as you can see, it's based on these acronyms. It's transparency, responsibility, user focus, sustainability, and technology. Sorry. So, but for today's talk, we will focus mostly on the first two, in the user focus and sustainability. Why user focus on sustainability? Why? Because the thing is that when we, as a technicians, now I myself consider a computer engineer and a mathematician, a statistician. So the problem is that I got one of the early projects as a data scientist. I got the feedback from my manager that I will remember all my life. The problem that you are having, Daniel, when it's not that how good is your model or bad is your model for our business. Your models are amazing. It's only that the way that you are expressing and let's say communicating this to the business need to be different that when you are communicating this to your other data scientists or a Scrum team. No? So that's why we will focus today on these two main principles, let's say. So for, as I like to learn from, let's say, examples, let's put a bad usual standard data scientist project. Normally, as any software development or solutions development, we start doing the requirements phase. Over the time, as you can see, there is a timeline here. You do the business objective, you do the solution design, model creation, evaluation, etc. No? But the problem is that normally, as technicals or data scientists, we focus a lot on this part when we do the communications. When we get into the head of a data scientist, we see this. Let's say we see that this is the process. We did already the ATL, we did the data exploratory phase, and now we have we do the data preparations, and the data preparation in this forecast sales analysis that we need to prepare is having just 3 years sales for whatever product. We need to do a selection of time series. We need to do a selection of packages that we're going to use, caret, forecast, whatever we want to use in R. All these selections that we are having in blue in here is selections that sometimes we are communicating to business. But this is a thing that is way too complicated for a person who doesn't have the knowledge, so technical knowledge. So over these selections, we can also do the selection of the method. For instance, in this case, we have 4 types of methods that we can select. We can select native or average approach. We can choose whole winter exponential smoothing. We can use ARIMA and all the type of parameterization that we need to do for this modeling. So this kind of parameterization and selections, normally a person who is on sales or in planning or people who work in finance, they are not trained on this. They don't know R, they don't know Python, they don't know sometimes many programming languages. And then we need to do the validations ourselves with forecasting or accuracy. No? So normally when we get out of the head of our data scientists, then we do the solution deployment. We include all the, let's say, engineers for putting this to production. And sometimes we do a maintenance of this. Let's say we do some tuning over the years of the modeling. But the problem is that I discovered many times following my experience is that we are delivering to our business actually a black box. And this black box plus a negative trust is bringing a fail. So the same, let's say, model that we have in green here, it fails after 3 months because nobody is using it. And I don't know you, but I really hate to, I don't like it to develop and spend so much time in some things that then they are not used. No? So let's focus why this is a problem. The problem is what I was explaining. This is a black box that the business doesn't understand what it's getting. They only what is happening inside of this black box. No, they only see what is getting in. There is multiple data sources, and it's whatever is getting out. There is their green arrows. There is the output that they need to trust, like the new truth for them. They need to rely all the planning and all the business decision on these green arrows that they even don't know where they are coming from. So for them is a thing that when you, for a human, it's really complicated to actually base all your work, daily base, on things that you don't know what is happening underneath. This abstractions is really complicated for them. No? So how to solve this? So let's focus on a better approach. So as you can see here, we have also a timeline but over the time, we have a user who is following us over the whole time. And we do kind of the same steps that we were doing the let's say bad approach, but we integrate the user as a new, let's say, stakeholder over the process. We do all the objectives definition. We do the prototyping, and we validate together with the business, but we validate inside of a data scientist team. And then we provide this to the end user to do the validation themselves, and then the solution deployment will be, let's say, a success. So let's put this, like, say, beautiful, better approach on working, no? So let's say that this is our case, no? Like one sample. We get from our sales, the finance, let's say from the C-level, we get a request that the previous year forecast was horrible, and that they wanted to narrow down this problem, and they wanted to do it over this year to focus to do machine learning and all these keywords that everybody is using nowadays. So during the Q2, we did already, let's say, as you see here, the timeline is divided in Q3, Q4, January, and February. But in Q2, we already did the requirements. But during the requirements, we only not listen the C-level, all the management. We use also we integrate into the process the people from finance, from planning, from logistics, to actually get the feedback from them, what is actually a good solution for them. Then we focus, we did this, and then we do this. Like, let's say during the Q3, we were developing all the machine learning part, all the modeling, all the things that we need. And then for Q4, we actually deliver every output depending on the timeline that they are needing. So let's say weekly or monthly, or depends of the business every 2 weeks. But in the same time, these outputs are not used for the business. It's a kind of, let's say, quality assurance. We are using these outputs, and the business still using the old method. So the old method that we're using for forecasting before, and then over January, they are able to, we say, okay, the quarter is ending, so this is the output that will deliver to you. You have your own outputs that you were using with your own method and system. So you can validate yourself. And then normally, most of the time, my experience is that after this validation themselves, they actually they don't see this as a black box. They see more like a partially transparent box. And when you already earn the trust, that is the keyword of this presentation, and you launch your model and solution with success. I don't know how I am in time, but I think I can present another small example how to communicate this to business. So another example of how to communicate to business is let's focus, for instance, on a problem of cash collection for accounts receivables. So let's say that all the yellow stars that we have here is open invoices, and we give credit to our customers of 30, 60, or 90 days, as the flex is reflecting. No? We wanted, if it's today, how many of these invoices will be actually on time, and because cash is a key for every business, and we can see nowadays on COVID time that the cash is actually one of the biggest assets for every company. So let's say that we go a bit even down to the business. We say this is the abstraction that we will use over, and the features that we will use over the modeling. So we will take, this is a kind of, everybody should understand this kind of chart, that you are explaining that today you are getting an invoice, that is this yellow star, and you are giving to the customer 60 days to pay you. No? And you wanted to know if this will be overdue or not. So what you are saying to the people who don't understand data scientists is like, we will use all the historical data that we have on our systems. We will analyze what is the overdues and no overdues, that they say the overdue is the one in green and the overdue is the one in red. And based on this model, we will do a classification and clusterization of the customers. And then when the business gives us a threshold, as you can see here, about the average or about the average. So let's say that some threshold that where they say, okay, when we have a customer who has more than 75% of paying late, we need to contact them earlier on the time. And with this small sample, I just, I just wanted to thank you, Marchie, and the whole team. And dropping the micro, I will be happy to reply your questions over YouTube chat or through my LinkedIn. You always can use Slack of the YR conference.
Okay, thank you, Daniel. That was a really inspiring talk. Happy to have you here tonight. And let me just have a look at the stream if we had some questions regarding your presentation. And okay, alrighty, almost there. Maybe let's start with a question from me. Could you a bit describe the history about your Polish position, where you were here, where you stay in Poland? What was it? Where did you live? Who did you meet? Who did you work for with?
The question is not why I was there. The question is why I was not before even. I spent 7 years in Poland. I'm really, I feel Poland like my second home. I'm currently living in Spain, but I'm going often to Poland. I really like the people, the food, the culture. So I love it. I love it. How I started, I don't know. To be honest, it was a mix of things that bring me to Poland. One of the things that I'm a really passionate person and ambitious, and I was looking to be able to work in projects that is challenging me. And I was finding this in IBM and General Electric in Poland.
Okay, thanks. So the talk was related to trust. Do you think that a data scientist position is a role that people trust on the street, like like a country president? People trust such people, but for a data scientist, are they trusted? Are we known to be magicians? How is that from your point of view?
I think that, as I was trying to explain over the presentation, I really like to get into technical details, as the guys from statistics were doing. But the problem that I realized that is going against the wall when you actually don't understand the business. Because many times, many times we wanted to do the best forecast with ARIMA, plus we are fulfilling all the data that we are missing with some other methodology. But then what they actually wanted is just a naive approach or a single average approach. So you can start this as a baseline, and then you can move from there. And then when you earn this, let's say, trust, they're not going to see you as a magician, because a magician is not welcome in a company never, because they don't see it like you are doing, let's say, a real job. It's just that you are bringing something that is smoke, no? And normally people from in the professional way don't like smoke sellers, let's call that, no?
Alrighty. In terms of distrustful automations, do you think a data scientist will be replaced in 10 years, or there still needs to be a human input?
I would love that. So that means that we will have a lot of jobs in the next 10 years. I think that we are, there is a hype on deep learning and artificial intelligence. Makes sense because we are growing a lot about the data gathering and power that we are able to manage. But I think that we are far from that moment that we will be replaced by the machine. especially for the thing that I'm telling you. If you wanted to put a machine to actually do a data scientist project, you need to put a machine who speak business language. And many times this is the hard part, because many of the deep learning models that are today, they are not even to speak properly. So let's say if you need even a translation for the words of business to a modeling or statistical approach, yeah, I think maybe 30 years can be. I hope at that moment I will be retired.
All right. So the moment we are retired, we can let the
Yeah.
machine take the control. Okay, Daniel, I think that's a wrap. Thank you for joining, for the
Thank
time
you.
that you invested in the presentation, and for your patience. And I'm looking forward to your future talks next year at our conference. Is that possible?
I hope that I will be present this time.
Oh yeah, in
So
person.
I will be glad to visit you in Warsaw.
Okay. Thank you, Daniel.
Thank you.
Bye.
Bye, everyone.